Hey mathletes, this is section 3.4a, solve systems of linear equations in three variables. Back in the previous lessons it was two equations, two unknowns. Now we're bumping it up to three. Three equations and three unknowns. And I just want to say real quick, there's a really big idea in math, and that is if you come up against a problem that's really difficult or new or strange, transform a difficult problem into a simpler one that you do know how to solve. So, and it's going to come up kind of big here because that's what we did before. We took two equations and two unknowns and turned it into one equation with one unknown, and that's what we solved. And we used that result to go back to the original. Well, here, I hope that you learned how to. I hope you learned how to do two by two equations, because we're going to use that when we get to three. So the basic idea here, the big roadmap is going to be, if you have three equations and three unknowns, you're going to try and transform that into a two by two. And then once you've finished that, the idea there is to turn that into a one equation with one unknown. So we're going from three down to two down to one. And last lesson we talked about how to go from two down to one. Now we're going from three down to two down to one. So you're going to need to know what we learned already, and it's going to show up kind of big here. So and on Math Excel or in textbooks, you might see three equations and three unknowns. You see M and P, N P P. There's three equations here and three unknowns, and so the technique we're going to use here is we're going to use substitution. I'm going to start off with the simplest one over here, and I think I can figure out what P is. So if 2p is equal to negative 10, then dividing both sides by 2, you get this. And now I can substitute this answer into here. And instead of p, I'm going to write what p is equal to, which is negative 5, and solve. Adding 5, dividing by 5, you get n is equal to 5. Now I'm going to take that number and that number, and I'm going to put them in, substitute them into here. The only thing I don't know is m, but I can multiply and combine like terms and solve, and I get that. So we were able to do this because we were able to use substitution. But sometimes we're given equations that are more simple. Like this one equation is pretty straightforward to solve. Sometimes we're given three equations and three unknowns all at the same time. So x, y, z, x, y, z, x, y, z, three equations, three unknowns. We're going to have to use the same technique over here. We're actually going to use elimination. And the first thing I think we should do is, honestly, we have to figure out what the roadmap is. We have to get. I'm seeing this x. That's kind of. I'm going to use this here. I'm going to use an x that either has a negative 1 or 1 as a coefficient. I could have equally just looked at this y or looked at this z, but I'm going to focus in on the x. Because it has a negative 1 or a positive 1 here. The roadmap here is to create two equations with no x. And if I could somehow take these equations and produce two new equations that only have y and z, then I'd be able to solve those. I would be back in this territory here. Here's two equations with only two unknowns. So you see there's no z, and that's solvable. We know what that looks like. So I'm going to try. The really big idea in math is to transform a difficult problem like this into a simpler one that I do know how to solve. So I'm going to try and create two equations with no x. In order to do that, in order to keep track of things, I think what I really need to do is I need to label these equation A, B, and C. Before I was talking about red equation, blue equation, top, bottom. I think it's complex enough that at this point I just need to actually label them. And I'm going to label them throughout using those letters, just so I don't confuse myself. All right, so first step is I'm going to use elimination. I'm actually going to break this up into two different parts. I'm going to recopy A here. It's just the same, no change. And B, I'm going to multiply it by 3. The reason I'm multiplying equation B by 3 is so that I can get elimination. I'm seeing this positive 3x here. If I multiply the B equation by 3, it'll be a negative 3x. And this is something that if I add the two together, I will create a new equation with no x in it, which is what I'm looking for. It'll only have y and z. I'm going to use that B equation again. Here, just recopy the c, but instead I'm going to multiply the b equation by 5. And if I do that, then I create a 5. It was negative x, now it's negative 5x. And this might look more complicated, the numbers are higher, but it's great because I have a 5x and a negative 5x. And if I were to add these two equations, the 5b and the c, add them together, I would produce an equation with no x. So, let's combine them. Let's add them together, and when I add them together, I get these new equations. There's 1y plus 6y is 7y. Z plus negative or minus 9z is minus 8z. 14 plus negative 27 is negative 13. I'm going to add these two together. 10y minus y is positive 9y. Minus 15z plus 5z is minus 10z. And then adding these two numbers together, you get negative 15. Great. Now this is two equations, two unknowns. We can use what we learned last lesson to go from two equations, two unknowns, down to one equation with one unknown. And it's going to be elimination again. I have to find the least common multiple. If I wanted to eliminate the y's, it would have to be like I need to create a 63y and a negative 63y. I think I'm going to go a little bit lower because the least common multiple between 8 and 10 is 40. So I need to transform these equations into equations that have a positive 40z and a negative 40z. The way that I want to do that is I'm going to multiply this top equation by, I'm sorry, I wanted to call these D and E. Maybe that'll come out later. D and E. This is equation D, this is equation E. They're new equations, and I'm going to multiply this top equation by 5, the D equation by 5 to get the equation that has a minus 40z. I'm going to multiply this equation, I'm going to call that E, by negative 4. And if I do that, and I get negative 4e, there's a positive 40z here. Great. The numbers might be a little bit larger, but I have a 40z and I have a minus 40z, and if I add these two equations together, just like I did last lesson, then I get one equation. I'll call that equation f. It's a new equation. F has negative y is equal to negative 5. Solving it, you get y is equal to 5. Great, I actually have one of the variables. I'm going to take that and put it back into this one of these two equations. I'll put it into equation E down here, and I get 9 times no longer y, but 5 minus 10z equals negative 15. Just rewriting this equation E with a 5 in it. I guess I forgot to delete one of the cover-ups here. All right, so y equals 5. I figured out this is one equation with one unknown, and I can solve it. I'm gonna and when I solve it, I get z equals 6. So I know what y is, I know what z is. I need to go back all the way to the original, and I'll use equation C. No real strong reason why I could have used any three of these, but I'm going to plug y and z in here, and I just don't know x, and when I solve all three of those, I get x equals 1. Wow, okay, so I now know what x, y, and z are all going to be. That's a long, long process. Let's back up and say and talk about what we did. Very first, we labeled our equations, and we singled out one of these that already has either a negative 1 or a positive 1. I rewrote, I took these three equations, and I produced two different equations here that we're going to eliminate. 3x and eliminate with no x. This when you add these two equations together, you get something that has no x. When you add these two equations together, you get something that has no x. And then I used all the techniques that I remembered from last class and last lesson to solve these two. It was kind of difficult. I had to get a negative minus 40z and a positive 40z. But when I add these two together, the z's eliminate, and I know what y is. I use that to find z, and I use that to find x. Wow, that's a long process. Let's talk about what some things that are required and some things that are recommended. Mathematically, it's required that the new equations must have the same two variables, like you see right here. The new equations had y and z, y and z. It wouldn't work if I had like x and z and y and z. That would not you wouldn't be able to use elimination there. So you have to eliminate the same variable twice. I eliminated x twice here. Next, you must use all three given equations. When I was using these three, notice it goes A, B, and C. If I had somehow used A and B up here and then A and B again down here, then that wouldn't work. It wouldn't arrive. I wouldn't be able to arrive at any new information to get the new equation, the new values. Only because I used A, B, and C in this step that was able to work. So that's what's required mathematically. Here's what's recommended from a studentship point of view. Students who eventually master this, and it takes a lot of work and a lot of hard thought, and a lot of cleanliness. You have to stay organized. Rewrite and label every equation. This A, B, C, D, E, F nonsense over here, it really does help. So make sure you rewrite. It's just a lot of handwriting also. I get it. I never liked the handwriting part of mathematics, but the more you take to it and the more you embrace it and the more you stay organized, the more likely it is you'll be able to get it right. And then next, elimination is easier when the variable has a coefficient of either plus or minus 1. Notice here, I zoomed in on this and I was like, okay, because there's a negative x here, I think I can pretty easily eliminate the x in the top and an x on the bottom. I needed to multiply this by 3 to get this, and b by 5 to get something that would eliminate here. Really focus in on those equations where it's not a 5 or a 3 or a 2, but either a plus 1 or a negative 1 as a coefficient. If you start to get fractions, you might want to double check your work because I don't know, the textbooks in MathXL generally are not going to choose values of y that are fractions. They don't. That would be really difficult to compute by hand. In the real world, solutions have decimal and fractional answers all the time. In the real world, in the world of big data, with millions and millions of variables and equations, there are decimal solutions all the time. But when we're doing it by hand, if you get in fractions, then you might want to double check your work. Next and last, if equations with less than 3 variables, maybe use substitution. So like up here, we saw an equation that had only 1 variable. Substitution is the way to go. Don't try and use elimination. All right, let's keep on going. Let's do this. We got 2 more problems I want to show you. This is basically going to look very similar to the roadmap here. However, there's one preliminary step. I noticed that just in previewing all these, all of the equations are this bottom equation, all the variables and even the number here, they're all even. So I think I'm going to go map 2 equations with no y. And why is that? Well, I'm going to label them, and actually I'm not even going to use this as equation C. I'm going to produce a new equation that has equation C like this. I'm going to divide all of these numbers by 2. So I get not 4x but 2x, not minus 2y but y, and 4z and 2z. Negative 14 divided by 2 is negative 7. The point is here, I'm going to, because I see the y, there's a 2, 4, 2, 4, 5, 3, 2, 2. But here, the y variable has a coefficient of negative 1. And that means I think it's going to be easiest to map 2 equations with no y variable. I'm going to create over here an equation that has x's and z's, and another one that has x's and z's, because I can eliminate y first. So I need 2 different equations. The top one I'm going to reuse, and then that's A. I'm just going to recopy it, and then B. Oh, here's another thing I noticed. If I just add A and B together, I get elimination already. Positive 5y and negative 5y. There's no multiplication necessary. I'm just using A and B. I'm going to add them together, and I get an equation with no y. Here, I'm going to recopy B, and then I do think I have to multiply it to eliminate this 5y. I need a positive 5y. So I'm going to multiply C by negative 5. The negative 5c version of this equation is negative 10x plus 5y minus 10z is equal to 35. Now I notice if I add these 2 equations together, the y's are going to eliminate. If I add these 2 equations together, the y's are going to eliminate. Great. And that's exactly what I do in the next step. the new equation, a plus b, is going to be equal to the d equation, 5x minus z equals -1. And then if I add these two together, I get negative 8x plus negative 8z is equal to 40. But I notice that all three of those terms all have a greatest common factor of 8. So I'm going to divide the entire equation by 8, or by negative 8, and I get x plus z is equal to -5. And I'll call that equation D and equation E. Wow. Okay, but I'm following my roadmap. That's two equations with no y. And this is an equation with no y, and this is an equation with no y. Great. I'm going to use the techniques I learned from last class to combine these two together. I don't even have to multiply. I can just straight up add, and the z's will eliminate. Add these two equations together, and you get 6x is equal to -6, which I can solve. Yay! X is equal to -1. I'm going to take that back into the equation E, and I forgot to uncover something. I'm going to take that back into the equation E, and when x is equal to -1, -1 plus z is equal to -5. When I solve that, I get z is equal to -4. There it is. Wrong order. Okay. Yeah, and now that I know what x and z are, I'm going to take that back into one of the original equations here. And yeah, right here, back in the original equation, c is equal to 2 times no longer x but -1. I don't know what y is. I do know what z is. I'm going to substitute and solve, and I get y is equal to -3. Sorry, that was a bit out of order. All right, next. I know one of the recommended studentship, if the equation has less than 3 variables, maybe use substitution. I actually could use substitution here. Look, these equations have fewer than 3 variables. I could solve for y. I could add 3x to both sides and then divide all 3 terms by -1 to get this. But I actually think that's harder. What might be easier would be a map with 2 equations with no x, because here's an equation with no x, and I can use this to create another equation with no x. So I think what I need to do next is I need to label these A, B, and C. I'm noticing that this x here is all by itself. It has a coefficient of 1, so that means I can use elimination. I'm going to recopy A. I'm going to recopy C. But I'm going to multiply C by 3 first, because I want to eliminate this -3x with a positive 3x. So I get -3x, 3x, and then this becomes 4y becomes minus 4y becomes minus 12y, plus z becomes 3z, 4 becomes 12. And now when I add these two together, I get something that will eliminate the x's, and I'll have an equation with no x that only has y and z. Minus y and minus 12y is minus 13y, and then there's no z term here, and then the 3z, I'm just going to keep the 3z here. A little tricky. Minus 8 plus 12 is 4. Great. I'm going to recopy equation B, because I need to use it. I used A, I used C, I gotta use B. And I'm noticing that y here is all by itself. So now I'm back to the previous lesson. I have a 2 by 2, so that's y is equal to, we've got a yz. So I'm going to multiply B by positive 13. Why positive 13? Because if I do, then I'm just going to recopy D. Then I get positive 13y and negative 13y. I saw that back here. So multiplying the entire top equation by 13, I get 2 times 13 is 26, 5 times 13 is 65. I'm going to add these two equations together to get equation, we'll call it equation F. The 13y minus 13y eliminate, and we get this negative 23z is equal to 69, which we can solve, that means z is equal to -3. Wow, okay. Now I'm going to back substitute. I use what z is in this top equation right here, B, the b equation, and then I use that to figure out what y is when I solve. I'm going to use that. Now that I know what y and z are, I'm going to take it all the way back to the original, and I'm going to plug in here into, say, equation A. Negative 3x minus y, I know what y is, it's negative 1, equals, I'll let you figure out what's underneath the dot, but then x equals, I gotta move my head. Then I can solve this equation and I get x equals 3. And now I'm done. And let me tell you, my voice is pretty hoarse. I'm going to go upstairs and I'm going to get a cup of tea. What's my favorite tea? It's Bengal Spice tea. Tastes just like chai. Bengal Spice, y'all. Get some. Yum. And I'll see you in class. Take care.